Question 4 is all about momentum. We get given these two particles, A and B, and then we have this collision between them. We get given all these numbers about the speed and the mass, and all of that is all about momentum. So let's try and map out what we think is going on. Here we have particle A. Let's draw particle A over here, and we get told, okay, so A and B are moving on a smooth horizontal surface. The mass of A is this before the collision. So before the collision we have 5I plus 18J. That's the speed that this thing is going at. So I should just say, let's go down here and say that this direction, if that was a bit straighter, would be J, and this direction would be I. So then this going left is negative I and going down is negative J. So what do we have? We have here, we have going this way, we have momentum of 5 times 6. So the speed times by the mass gives you the momentum, and going upwards we have 18 also times by 6 to give us that. And then we have particle B. So let's do that over here. Let's label particle B there. So we have 2I, so going this way we have 2 times by the mass, which is m, and then going down the way, downwards, we have a mass here of speed of minus 5, and again the weight is m. So that was before the collision. Let's draw a line under that and say, okay, now what's happening after the collision? Let's use the same colour. So A is just 8I, so it has no vertical momentum anymore, no vertical speed. It is all horizontal. So we have it's 8 times by 6, and then for B has no horizontal momentum anymore, just vertical, and that is, we don't know if it's up or down, so could be up, could be down, but anyway it is V times by m. That is the momentum that we have. So let's give ourselves the total horizontal, to start off with, horizontal energy or momentum. In this case they're synonymous. So the total horizontal energy, let's work out that. So this is going to be 30 here, this is going to be 48, and this is 2m. So before the collision we have 30 plus 2m, and after the collision we have 48. Now the crucial thing here is before the collision has to be equal to after the collision. So the energy in a horizontal direction or a vertical direction before has to be exactly the same as afterwards. So we get this equation here where we can solve for m. We can find out what m is by doing that. This is before and this is after. So by doing that we take away 30 from both sides, we get 2m equals 18, and from that we get m is equal to 9. That's how we find out the answer to A. I know I'm doing this in a kind of let's solve for everything way, but the first question, the answer is 9 kilograms. For that is the mass of B there, that's the mass of that particle. So then find V. Well, we can find out what that is by doing the same thing as we did horizontally, but do it vertically. So the total vertical energy, that is going to be equal to, here we have, this is going to be, what is 18 times 6? 18 times 6 is 108. So let's put that in there, 108. and then here it's going to be minus 5m, so minus 5. Now we know what m is. M is 9, so we can do minus 5 times by 9, and it also is equal to v times by 9 as well. So final part, we can solve this by going 108 minus, that's going to be minus 45, is equal to 9v. What is 108 minus 45? That is 63. So 63 is equal to 9v, which means that v is of course equal to 7. So 7 meters per second there. So we know that now this is not going down anymore, this is up. This is a positive 7 meters per second, and that is our answer here, 7 meters per second. See you on the next one.